Jacob said he would. Well, that was nice of Jacob. All right, so these are just the formulas from yesterday. So once we were given stuff about a population, we were able to find the mean and the standard deviation for the sample. And then once you have a mean and standard deviation for a sample, then we can do a sampling distribution with the mean in the middle, and then we add the standard deviation to get the three numbers to the right, and we subtract it to get the numbers on the left. But we always use the standard deviation from the sample. When it says sampling distribution, you get the information from the sample. So we are going to calculate some probabilities today. So I just wanted to remind you guys, make sure that if you're finding the probability that you do draw the model and shade. So like what we did in chapter 18, where we drew the curves and we drew the lines and shaded the area. Sometimes it was greater than, sometimes it was less than. And make sure we're shading the correct way. And then just like we did in chapter 18 with proportions, we are going to use the calculator to find, and let me... All right, so anytime you see the words greater than or less than, to find the probability, we are going to use that normal CDF, that cumulative distribution function. That just means we're finding the probability of a shaded area on a graph. And the calculator instructions, I just wanted to refresh on those. It's like you hit the second and then hit the distribution menu, and then the second choice is that normal CDF. And once you open that, we will be shading our curves, and so the lower bound or the lower number is always that smallest number that you shade. The upper is the biggest number that you shade, and then the mean and standard deviation are coming from the sample. So the mean and standard deviations that we calculated yesterday, we're going to use those to make the curve, and then we'll put those into the calculator as well. And I only did 3 examples today since we did these normal distributions with proportions. Today it's just with, instead of decimals as your mean, it's going to be whole numbers. Whose back was that? Woo! That was intense. I will say though, those desks are like the best for back popping.
Gunnar Bowman at baseball, he can pop your back. Like he'll have you lay on your stomach and put your arms like above your head, and then you'll breathe in, and right when you start to breathe out, he'll just push on your back, and it's awesome. Yesterday. Ray was there yesterday.
All right. Is anybody still writing this information, Will? Or okay. Jacob, come on.
Did Zach tell you Lucy tried to pretend like the door wasn't unlocked?
She told me it was locked. He said he forgot to unlock it.
Oh, I thought she was fake.
No, it was really...
She's like, dang it, I guess I have to go with you home. I was like, what? No, I was like, oh, your dad told him that's his truck. And she's like, yeah, but he's really busy, so I'll just go with you. I don't think so. I'm pretty sure I have to go to work tonight.
No, I thought I was going to have to go back to Joe's last night. She thought she forgot her egg, but we found it.
Oh, thank goodness.
Hey, Lexi. You know, say just leave a little space on your notes, and we've just wrote down some general information. You can go back and write this later. All right, Dawson, are you ready?
Yeah.
Will, are you ready?
I'm good.
Everybody else good? Annie, are you awake today?
I'm here.
Okay.
She's just doodling.
Oh, okay. All right, so let's actually do just a quick reminder. You wrote this yesterday, so don't feel like if you have this somewhere, don't feel like you have to write it again. But I just want to remind you, if the sample size is smaller than 30, if it actually tells you that the population is normal, we can assume the sample's normal and draw the curve and do all that stuff. If the population is, if it tells you it's skewed, that means the sample's skewed, so you cannot draw the bell curve. If it doesn't tell you what the population shape is and it's a really small sample size, we also don't know. So this one here is the only one that you can draw the bell curve for. If it tells you the population's normal, then we can assume it's normal and do the bell curve. If it's skewed or unknown, and it's a really small sample size, we actually can't answer, like we cannot find probabilities with the normal distribution. So if you have a problem today on your assignment and your sample size is like 10, make sure you look at this, because if it doesn't tell you that it's normal, you cannot answer the question. So just make sure you pay attention to that when you're working on your assignment today. Now, we wrote this yesterday, but it's on there again. So the only one we can actually do work for on a small sample size is if they actually tell you that the population's normal. I will tell you guys, it took me a year, but I finally found my favorite mask of choice. It was a random, like, it was, I don't know, like clickbait. And I was like, these look really nice. They're mesh. And so there's like a lining of mesh on the inside, and there's like a little pocket, so I feel like I'm not suffocating. And it actually and it doesn't like kill my ears. I don't know, it's very nice. It came in a 3-pack. Hopefully these are like the last masks I buy, but no, it took me a year, but I finally found one I like. All right, so I am ready to do an example. Are you guys ready? Do you have your graphing calculators? Because you will need it. All right, get those out, because for our first example, I'll say let it. All right, so we are going to talk about, I don't know why eggs, but eggs from a company have a normal distribution with a mean of 70 grams and a standard deviation of 2. So we're talking about the weight of an egg. So all of the eggs from a company have a normal distribution with a mean of 70 and a standard deviation of 2. And we are going to do a sample carton with 4 eggs. And we want to know the probability of the mean weight of the package. And I want to know what's the probability it's going to be less than 68.5 grams. All right, so in this scenario, what's the population? I'm going to say, what's the big group that we're looking at? eggs from the entire company, right? So eggs from the entire company is the population. All right, so it gives us the mean and the standard deviation for that. What is the mean weight? 70 grams, and the standard deviation is 2. Now, in this case, it tells us that the sample is 4 eggs. All right, that's a really small sample size. But why can we go ahead and draw a curve for this one? All right, it tells you on this one, it does say that the population is normal, so we can, even though the sample size is really small, we can go ahead and calculate a mean and a standard deviation for this sample and draw the curve. So the mean is just the same as the population, so our mean is 70. Now for our standard deviation, we have to do a little bit of work. All right, so we just wrote it earlier. What is the formula to find the standard deviation of the sample size? All right, standard deviation divided by the square root of n, and so we're going to take 2 divided by the square root of 4. What's 2 divided by 2? Just 1. So the standard deviation of the overall population is 2, but when you cut that down, it does shorten it up a little bit. So this information here from the sample is what we're going to put in our graph. So we are able to draw our bell curve. So I'm going to just darken it up so it shows up a little better. All right, so we've got our mean of 70. It's going to go right in the middle. And our standard deviation is just 1. So then we're going to add 1 to go to the right side and then subtract 1 to go to the left. All right, do you guys feel like we've done this enough? Are you guys okay with making the curves? All right, now on this one, we are trying to find the probability that the mean weight of our sample size is less than 68.5. So we are going to mark this and shade it on our graph. So 68.5 is right here, right in the middle of 68 and 69. And which way am I going to shade if I'm talking about less than? Left or right? All right, we're shading to the left. So I want to know the probability that if I get a carton of eggs at random, these small packages of 4, if the average is going to be less than 68.5. All right, now remember, we have to do probability notation with this as well. All right, so this time we're talking about the probability. And since we're talking about an average, we use X bar. All right, what am I going to put on the else in here? We want X to be what? Less than or equal to what number? 68.5. All right, so once we have this, we are ready to go to our calculator. So we are going to do that normal CDF. And we have to write in our lower, our upper, and our mean and our standard deviation. All right, so I'm actually going to switch views so it's a little bit easier for everybody that's watching this to see the calculator without the glare. Okay, so on this one, you are going to go second and hit that distribution menu and go down to your normal CDF. not let me? All right, so my lower is always my smallest number that I'm shading. Now, right here, it starts from 68. Now, obviously, this could go all the way down to 0. But you honestly, as long as you're picking a number in your range that's way less than 67, like I will tell you for your lower, if you put in 60 or 40 or 20 or 0, your answers aren't going to be that much different because they are so far away from 67 that it's going to change like by the 10,000ths of a decimal. It's just going to barely change. So as long as you are out of your range, like I would say for your lower on this one, as long as you are 60 or lower, you're going to be okay. So go ahead and enter 60 for your lower. Now, what's the largest value we shaded? 68.5 is our upper. And then your mean and standard deviation come from the sample. So our mean is 70. And what was our standard deviation from the sample that we got from the formula? It was 1. The population standard deviation was 2, but the formula gave us 1. So then we're going to paste that in. And it gives us a probability of 0.066807 and a bunch of other stuff. All right, so now I can flip it to where you guys can see. So if you type all of this in, are you getting the same number as me? All right, and let's just say, let's at least round to 3 or 4 places after the decimal. So if you guys had 0.0668 or even 0.067, I would be okay with either one of those. And does it make sense if we're only shading a little bit of this tail that the probability is only about 6%? You know, say the bigger the area you're shading, the bigger your probability is going to be. Big chunks in the middle are going to have a bigger answer. I'm gonna say, do you guys have any questions on that one? All right, now I like this second question. All right, I took this from another example, and it's saying that a study of 750 adults shows that the average amount of sleep is 10 hours with a standard deviation of 2. I would like to meet these adults that are getting said 10 hours of sleep. I don't know where they're at or where they live or what they do, but it would be nice to meet those people. I'm kind of jealous. All right, so then we are actually going to take a sample of 100 adults. We're going to take a sample of 100 adults just to see if this is accurate information. And we're going to find out what the probability is that the mean of the average hours of sleep is farther than 0.4 hours away from the mean. All right, so first of all, can we assume that this is a normal distribution with our sample size? Is our sample size bigger than 30? All right, our sample size is bigger than 30. So our population had a mean of 10 and a standard deviation of 2. But we can go ahead and calculate the mean and the standard deviation for our sample. So our sample size is 100. All right, what's the mean going to be? I'm going to say, does the mean change ever? No, the mean's going to stay 10. Now, whenever you change the sample size, it does change the spread. So if we take the standard deviation and divide it by the square root of the sample size, what is 2 divided by the square root of 100? I'll say, what is that?
Say 2 times the square root of
No,
100?
2 divided by the square root of 100. 0.2. Because wouldn't that be 2 over 10, which is just 0.2? All right, so once we have this information, we can go ahead and build our curve. All right, so what is going to go in the middle? 10 goes in the middle. And then we are using the sample information, so our standard deviation of the sample is 0.2. So then we're going to add 0.2 to everything to the right, and then we're going to subtract 0.2 to everything to the left. All right, now, where do you think we should shade here based on the question? It says we want to know when the mean is farther than 0.4 hours away from the mean. So what's it mean if it's farther than 0.4? What do you guys think? All right, anything that's above 10.4? So this is 0.4 away from the mean. So would you guys agree that any of these areas would be farther away than 0.4? It also would be the other way. So whenever you read this question, it doesn't say more than or less than, it just says farther than. So whenever you see this farther than, you have to think of both directions. So this one is 10.4 and above. Now where am I going to shade on the other side? 0.96 and below. Now, one thing that is nice about this, normal distributions are symmetric. So do you think that the probability of this tail should match the probability of this one? So you really just have to find the probability of one and then double it. All right, so do you guys want to, let's find this one and then we'll double it to get the other side. All right, so we are doing that normal CDF, but all right, now what am I going to put in for the lower into my calculator for this one? 10.4 is going to be my lower. Now this one's going 10.4 and up. What's a number that's...
I put 12.
You put 12? I mean, 12 would be fine. Now, is 11 probably too close? 11's probably too close. I would say if you pick anything beyond 12, I don't know, let's just pick 15, just for fun. All right, so you can pick any number for your upper that's way off the graph. Because honestly, we could shade this. This could go on forever and ever and ever, but 15 seems reasonable. And then our mean was 10 and our standard deviation for this was 0.2. So let's type that in. And we go to our normal CDF. Our lower is 10.4. Our upper is 15. Our mean is 10 and our standard deviation is 0.2. All right, so this information right here, are you guys getting somewhere around 0.023? Something in that. All right, so if this is 0.023, We can also assume that this is 0.023. So when we put those together, what's our probability? And say if we put those together, what do we get? 0.046. 0.046, because we just have to calculate the one side because we can assume because of symmetry that it is the exact same on the other side. I'm going to say, I don't want to go too fast, but do you guys have any questions on this one? All right, so for our last one, are you guys ready to try this one on your own? All right, so here is the first part. I'll give you guys some time to do this. So make sure we are using a sample size of 100 homes so we can assume that it's normal. Make sure you know your mean and your standard deviation for the sample before you make your curve. Make sure you find both of those first. You guys agree with my mean and standard deviation
No.
for my sample? Because you got to divide by the square root of the sample size. So you're going to take 60,000 divided by 10 to give you 6,000.
When we do the bell thing, whenever we go from like 140,000 like up or down, do we just do like 140,000 and $1, 140,000 $2?
No.
Or just do like 141,000 or
You
oh,
add
yeah,
by
standard
the
deviation.
you add by the standard deviation. So when you do your curve, 140, and I'm just going to put K's because I don't want to write all my zeros. You can do this as well. So if I'm adding each time, the standard deviation of my sample size is 6,000. So what's going to be my first when I add? Yep, that's going to be 146,000. My second one, 152,000, and my third one, 158,000. And then the other side I subtract, so I get 134,000, 128,000, and 122,000. And that is the worst bell curve I think I've ever drawn in my life.
Can we do the part B? We had to do the story.
Well, you don't have the rest of the question. Now you do. All right, so I want you guys to go ahead and find out the probability that you would pick a home and the value of it would be 150,000 or more. So where would you draw a line on your graph and where would you shade that? And then once you have that shaded, then you can put it into the calculator. Now say, what do you guys get for a probability for this? 0.048. Now say, Delaney, are you getting that? Okay, now I have to ask. Whenever you do this, you should have on your graph, you should make a line in between 146 and 152, a little bit closer to 152. And we are going bigger. So what did you guys put for your lower? 150,000. Now whenever you type it in here, you do have to put the zeros to make it work. Now what did you guys put in for the upper? You put 200? Did anybody put anything different? You did 180? I did 165. All right, so do you see here? You guys all put in different values, but we all still got 0.048, right? So I did 165,000. Now, if you guys chose 180 or 200, you can write whatever. You just have to write that to show your work that you know what you're talking about. And then our mean is 140,000, and our standard deviation is 6,000, and I got 0.048. Now, if this were a quiz or a test, I would want you to draw a second curve, but I'm not going to make you. All right, so I've got one more for you. For this same problem, what would be the probability that a home is selected and has a value between 130,000 and 135,000? So, first of all, where would we shade this? I'm going to copy the curve, but you don't have to. So if you did this, where would we shade this one? Jacob, where would I shade this one?
Between 130 and 135.
All right, so do you agree 130 is a little bit after 128?
Yeah.
And where's 135 at?
Right after 134.
So then we would draw those and then we would shade this, right?
Yeah.
All right, so when you do your normal CDF, that's one thing that's nice about the ranges is it actually gives you your lower and your upper. So our lower is 130. Our upper is 135. And then our same mean and standard deviation, since it's still part of the same question. So we got 140,000 and 6,000. So we can type that in.
Teachers, please excuse the interruption. Lane Pinkston and Joe McGowan, please report to the office.
Mean and standard deviation didn't change. Did you guys get 0.155? And we got our probability. Now, if we wanted to do this, technically we should be doing probability notation. So on this last one, we should have actually put the probability that X is in between these two. And on part B, we should have done probability that X is greater than or equal to 150,000. You know, say do not forget to put those on your assignments, because that is one thing with the AP test. You get a point just for doing probability notation. So on those free response questions, in order to get the 4 out of 4, you have to put that. And it's, I mean, it's a very simple detail that's easy to forget, but it is needed to get those 4s. Mm-hmm. Which one? Yeah. Is it this one?
Yeah.
Sorry, I have it curved, so it's, let it refocus.
And then when is today's Hanukkah?
Okay, so if you guys look on Canvas, yesterday's Khan Academies will be finalized tonight at midnight. And then today's Khan Academy is tomorrow at midnight. So like everything is finalized the next day at midnight. Yes. Hey Jacob, what were you supposed to remind me to do?
Stop recording.
Okay.